All right, so I am live with Assimilating Rust. The idea here is that I continue to just build off of Rust and demo a lot of cool things, and I've made a ton of progress in Rust. And so I'm going to make things a little more complex with this live stream. So I'm going to dive into some really cool stuff, and in particular, I think one of the funner ones that would be kind of nice to toy around with is this repo called Nogi BJJ Rust MLOps template. I have just a ton of demos. I do a demo, I mean, once a day, twice a day, 3 times a day. I'm doing just amazing amount of Rust. And in particular, what I think would be kind of a fun one to demo would be to use AWS Lambda. And I think this really shows how awesome Rust is for doing cloud computing in particular. And so what we could do is we could actually click on this link here and go ahead and open up a code space. Now, this particular code space for Rust is kind of an interesting one because I've enabled quite a few things, and one of the recent things that I enabled was the ability to basically interact with AWS. And so I'm going to go ahead and show you where that is. So I've installed AWS Toolkit. Now, what's cool about AWS Toolkit is that it will allow you to do this. If we just go through here and we say, US East Gateway, API Gateway, App Runner, all this stuff, right? We have all this stuff inside of here. But let me show you the really cool thing about what I just set up. I think it was last night I was playing around with this. Is here's a project called Rust AWS Lambda. And it's actually a very easy project. So how does it work? So here's our code for Lambda. Let's just get rid of this one. In fact, let's do this. Let's open up another terminal and let's bring that over here. Hopefully, there we go. That's what I want. So basically, if I cd into this directory, which is Rust AWS Lambda, let's first show the working Lambda, and then what I'll do is I'll just build it from scratch. So the README for this particular project is right here, and you can see here that I installed the AWS Visual Studio Code plugin, and I configured it for my AWS account. Then I looked at the AWS GitHub repo for Lambda and took a look at it. But basically, all you need to do is actually follow these instructions. And so I'm going to go ahead and I'm going to paste this inside here like that. And you can see here it is, AWS Labs, AWS Lambda, Rust runtime. And it shows you that it does need to actually install some like bootstrapping tools. And so if you're on Mac, you could just do a brew install of cargo-lambda. If you're on Windows, you can use Scoop. I've actually never used that. Or, probably the path of least resistance is you just do pip3 install cargo-lambda. And let me show you how you would actually set that up. So if what I typically do is I say Python 3 -m venv, and I would just make a virtual environment, and then I would source it. Now, I think I already did one, so I don't have to. I can just say source venv. There we go. Then activate. Right, so now, if I needed to install that tool, right, I could just do that command. That's it. There's just a one-liner basically to get things cooking, and you'll see it's already installed, right? So once that is installed, then it gives you the ability to use these kind of fancy things here, like cargo lambda new, and it'll just make a new lambda function. And then when you want to run it, you just say cargo lambda build release. That's it. This kind of one-liner, which is just amazing, right? In order to do it. Now, what's kind of cool as well is you can also cross-compile and build out like a x86 64 or a ARM one as well. So let's go ahead and kick the tires on how to do all of this. So the first thing I'm going to do is just basically look at the Lambda that I've already created here. So we can even go to our AWS tool And if we go to Lambda, we can, what is it called? Rust, AWS Lambda. Look, I can even invoke it if I wanted to in put in some payload, right? So that's one kind of cool thing about it. But even easier is I could just run this command, right? And notice how simple it is to run. If I just paste this into the terminal, that I say cargo lambda invoke remote, and it says here's the payload I want to send it. So I want to send a JSON payload, which is command hi, and then I want you to give me back JSON, and then it gives us back a response, which is this one right here. So we can even go into my AWS account and even play around with the one that was just created. So let's do that. Let's go to the console here, and let's log in. Just going to log in real quick here to my accounts, and we can do this. All right. So if I look at the Lambda here, we should see my Rust AWS Lambda. And here we go. This is what it looks like. This is what was deployed via that tool. If I wanted to test it, I could also individually test it. So let's go to this, which is a configure test event. And let's actually say, I think it's the payload it's wanting us to put in is command, and let's just change it a little bit. So we'll say command, and we'll just say Rust AWS Lambda. That looks good. Save it. And now if I test it, there we go. Command Rust AWS Lambda executed, right? So Rust made this trivial to do. So let's now redo this again and show how simple it is to build this out in AWS. So let's start from the beginning. In order to do a Lambda project, what I'm going to do is I'm going to make a new project. And so I can even follow the instructions here. So cargo lambda new. That's what we want to do. So we want to say cargo lambda new. What do we want to call this thing? Let's see if I can do a Marco Polo. Marco Polo. Let's try that out. And we'll call this Marco Polo lambda. Is this a HTTP function? Yes. If it's yes, it would be triggered by an API gateway or a Lambda URL. I'm going to say no. Let's not do that. Let's just say no. And then this receives, leave it blank if you don't want to use any event. Yeah, we don't want to use any event. Okay, so it created this. So now I'm going to cd into Marco Polo Lambda. And I can basically look at that and then look at the code that appears. So it did a pretty good job here. So it made, if we look at this, look, it added some like tracing things. It like built the whole project out for me, which is pretty cool. And then if we go to the main file, it also built out basically a structure for us to play around with. So this is the event handler here. And then this really just kind of ties everything together because Rust requires a main. Now notice this is also async here. So we don't need to do that much stuff here. And in fact, I'm going to just clean up some of these comments because they're annoying. There's just too much here. But I like that message ID. We can use the majority of this code. In fact, and what I like to do as well is I like to copy like a make file. And so I'm gonna copy a make file from my other project. So I'll see CP up, and we'll say Rust AWS Lambda make file to here. I'll tweak this a little bit. So what I will do is we want formats. I'm going to get rid of a lot of stuff in here. We don't need tests for now. Release, probably we want deploy. No, release, let's get rid of that. I don't need that for now. Invoke is going to be kind of useful. Marco, but we haven't deployed it yet though, so I'll have to tweak this. Marco Lambda, and we'll say instead of command, we're going to say name, and we're going to say Marco. That looks pretty good. That's probably what I want. And then now that we've got the formatting set up, what we can do is we can just say make format, because I think it's really a good idea to format your code. There we go. So it looks pretty good. And even prepare the response. Now, what I could probably do here is command. Let's change this to be name. And this is command is event payload command. And we want to change the payload to name. Like that. So we want to say name. And name here. Looks good. And what I want to do is put some conditional logic. Is we want to say basically if name is equal to Marco, then return Polo. Otherwise, who? So let's do it. There we go. So so I put a little logic in there. Looks good. If name is Marco, we want to actually, if the name is Marco, we want to assign to response. So let's tweak this a little bit. So we want to say let response to exactly something like that. So match name response, and then we want to say message format, and we want to say this. Perfect. That looks good. I like that. Okay, so basically I'm going to say, look, if the word Marco appears, do return back Polo, otherwise return back who. Again, Copilot is just shockingly good, right? And it's going to help me build all that logic out. So we're going to format it, and then we'll lint it, and we'll see what happens. So if lint passes, good sign. If it doesn't pass, that's a bad sign. But if it passes, it's extremely good sign. So it's looking good so far. And the next step then, and I'll put this. We should probably put a little README. Okay, we got a problem, which is not that big of a deal. So it says a local variable with a similar name exists. Yeah, it's true. I made, so it's kind of watching out for me. We'll say let logic, and then we'll change this to logic. That, and let's do make lints. Okay, only one bug now. So what I need to find the command. There we go. Struct. We need to change this to name, right? So this is why typing is so awesome. It helps me find bugs. Make lints. Let's see. Marco expected string found. So we also can help fix this. This is line 19. We need to, if we can say expected but found. Let's do this. We can say, see if Copilot can help us. So, you know what we can do? I think we could just say standard. Let's try that. Or even what I sometimes do is do this. I can say Let's see if it's smart enough to figure it out. Pilot, can it just magically logic? Does that work? We'll see here. Let's see if it can fix it. Did that work? There you go. Right. So you can see that I'm really treating Copilot as essentially like a pair programmer who's a lot smarter than I am because it is. I'm still not like a super hardcore Rust programmer, and it's kind of helping me be better. And so I can again format it, looking good. Okay, so now we're close to being able to do cool stuff. I'm just going to add a quick little README in here in case somebody traverses to this project, and we can just say like steps to run. And so we just say like make format code, and then we can say um, make lint to lint it. And now I just need to follow the guide from the GitHub. And let's see here. What do we need to do? We did all this. We did all this. So that's it. That's so if you want to just push it to production, you just do that. Now I am tempted to do this one because I haven't done the ARM-based release yet. And so sure, live demo, let's go. Let's go for it. So let's tweak it. Let's release as ARM, right? So we can see this. This will release an ARM version. So let's say make release ARM. Fingers crossed. Will it just work? So if it lints, good chance it'll compile. If it compiles, you're in great shape. And if it compiles, it'll probably deploy. Let's see here. Whoa, excellent. So now what do we do? So I think we could go check this out, right? We could go look at Marco Polo Lambda inside of AWS. Did it deploy it? Refresh. Last modified. Marco Polo. I don't see Marco Polo. Did it not deploy it? Do I have to do something else to deploy? I don't think it deployed. So what else is there? So we recommend that to build it. You do that. Oh, deploy. Now I want to deploy. Okay. So I have to do a build, then a deploy. Sorry. So the deploy is trivial because I already built it. Is now the deploy, I just say make deploy, cargo-lambda deploy. So let's do make deploy. So I'll put those steps into the README here, which is, you can say make deploy, which is that. Which is this. And then we say build for ARM, say make, what did I call that again? I called it make release ARM. Yeah, we did a release. Make release ARM, which is this one, like that. There we go. All right, so fingers crossed, we just do a make deploy. And again, because it's binary based deployment, this, in my opinion, blows the barn doors off of Python, because once you have a binary, it works. Look at this. Look how amazing that is. Right now, I can go back to my invoke and let's just invoke it, right? Which is right here. Let's try it out. Let's say make invoke. Boom. Right? Marco says Polo. I for people that are familiar with AWS Lambda, I would hope you would be like your jaw drop, like, whoa, this is cool stuff. Because it really is. I mean, this is really cool stuff. So this is a working demo here. And now let's go back to our Lambda interface, Marco Polo Lambda. There we go. It's going to be pretty easy to test it out in the console as well. We just go here, we say configure test event. And then we say hello, or no, let's call this one Marco. And now we go to this and we just say name and say Marco. Format it. There we go. We tested. Excellence, right? So I think I've proved here that in fact this is fairly trivial to use Rust for AWS Lambda. And in fact, I would even make the argument that it's better than Python by a long shot. First of all, I think the latency is 10 times faster. I think someone had posted this on LinkedIn. And you can see it's just trivial to build code, and it's very reliable code and robust to deploy. So I'm going to go ahead and say get status. I'm going to go up, get status again, go ahead and add this, and let's go ahead and commit it. And adding Marco Polo. Perfect. So we'll do a get pull to get some changes, and then we'll do a get push. All right. So I think I've proven here today that it's a Rust in particular is a very good choice for doing AWS, and especially AWS serverless. And hope to see you again very soon to do more stuff with Rust. All right. Talk to you soon.